We're going to look at the problem of Gaussian elimination. Now, Gaussian elimination starts at the top and goes down to the bottom, whereas Gaussian Jordan elimination starts at the bottom and goes to the top. So, what is this matrix here? What does it mean? Okay, so this means that we have a system of linear equations. We have 4x plus 9y plus 6z is equal to 4. We have 3x plus 7y plus 5z is equal to 0. And we have 2x plus 5y plus 4z is equal to negative 4. Now you can choose any variables here. That's equation 1, equation 2, and equation 3. Okay, so there's two methods for solving these. There's method 1, which is to use normal simultaneous elimination. So I'm going to write simultaneous elimination, and we will do that one. And there's Gaussian elimination. Okay, so Gaussian elimination takes a normal matrix like we've got here and puts it into echelon form. Let's write that down. Oh, of all times. Okay, echelon form. Okay, so echelon form means that the leading coefficients are 1. So we can just read off the values. So for example, in this matrix here, we would have 1, 0, 0, 28. We would have 0, 1, 0, negative 12. We would have 0, 0, 1, and let's go with, I don't know, 0. So we can read off straight away that x is 28, y is negative 12, and z is 0. Okay, and the ones, the terms which you want to turn into 1 is referred to as a pivot. Okay, so let's do method 1 to see what's going on here. Let's get rid of everything. Okay, so method 1 just uses standard elimination. Let's keep that up there. Okay, so let's have a look at method 1. Okay, so if we're using standard elimination, we'll do this in red. Let's multiply equation 1 by 3 and equation 2 by 4. Okay, so we're going to get 12x plus 27y plus 18z is equal to 12. And we're now going to call that equation 4. And we're going to get 12x plus 28y plus 20z is equal to 0. I'm going to call that equation 5. Okay, so let's subtract to get rid of the x variable. So if we subtract, we get negative y, negative 2z is equal to 12. Let's do the same for 2 and 3. So we're going to multiply. So let's get rid of the x's. And the lowest common multiple of 2 and 3 is 6. So we need to multiply equation 2 by 3. By 2 rather. 3. 3 is 9. Okay. By 2. And equation 3 by 3. So let's do that then. So we've got 6x plus 14y plus 10z is equal to 0. We've got 6x plus 15y plus 12z is equal to negative 12. Let's subtract them. If we subtract them, we get negative y, negative 2z, and we get that equal to 12. Okay, now do you see the problem? These lines are parallel, so either y is equal to 0 or z is equal to 0. So let's have a closer look at this. So this is the limitations of using the elimination method. We don't know which one. Okay, so let's have a quick look. So let's do y equal to 0. If y equals to 0, we know z is equal to negative 6 from this equation here. If y is 0, 12 divided by negative 2 is negative 6. And we can sub into equation 1 then. Let's do that. We've got 4x plus 6z is equal to 4. Well, we know that z is negative 6, so we've got 4x negative 36 is equal to 4. So we're left with x is equal to 10. That's a possible solution. So let's do z equal to 0. We've got y is equal to 12 from here. And then we've got 4x plus 9y is equal to 4. Well, we've got 4x okay, do we get negative 12? Okay, that should be negative 12, shouldn't it? It should be negative 12. So if you put negative 12 in there, we're going to get negative 108 is equal to 4. And then we're going to get x is equal to 28. Okay, so write those possible solutions down. Okay, we've got two sets of possible solutions here. This is the first set, and this is the second set. Remember that negative there. Okay, so you can see the limitations of this method. So this is going to be a marathon session, so let's use Gaussian elimination on that matrix to put into row echelon form. I'm just going to reiterate what row echelon form is called, actually is. So we have in the initial question, let's go back to yellow. In the initial question, we have the matrix. It's far too big. We have the matrix. We have this matrix. 4, 9, 6, 4, 3, 7, 5, 0, 2, 5, 4, negative 4. Okay, so we need to use Gaussian elimination to get that into row echelon form. And that means that we can read each of the variables of x, y, z. I like putting an equal sign there. So you're going to get and all the rest zeros. That's what it means. So we can just read off the values. So for instance, let's take case 1. X was 10, y was 0, and z was -6. Okay, so look, you've got 1x is equal to 10. So x is equal to 10, right? You've got 1y is equal to 0. Well, y is equal to 0. You've got 1z is equal to -6. Okay, now there's different methods for doing the row echelon form, but eventually you need to do matrix operations to get each line in this form. Okay, let's do this. It's going to be quite long. Okay, I like writing a description in the top, on top of the matrix, to describe exactly what we're doing. Okay, now let's split this page into 3 so I can show you everything that we're doing. Let's get rid of that as well. Okay, this is not difficult to do, easy to make a mistake. It's not difficult to do, but easy to make a mistake. And I would encourage you to check your answer using basic elimination first. Okay, if you practice basic elimination, you can do it in a minute. Okay, so let's do this then. Okay, so we start off with our initial problem. Initial problem is 4, 9, 6, 4, 3, 7, 5, 0, 2, 5, 4, -4. Okay, so we're going to make the first column the pivot. That is to say, we're going to get this equal to 1. Okay, now to get that equal to 1, we're going to divide first row by 4. Okay, so let's do that. Let's divide the first row by 4. We're going to get 1, 9 over 4, 3 over 2, when you simplify 1. And we are left with 3, 7, 5, 0, and 2, 5, 4, negative 4. Okay, we've got a leading coefficient of 3, so let's multiply the first row by 3, and then we can do some subtractions. So multiply first row by 3. Okay, so I'm using a calculator here, and it gives the simplification straight away. Okay, so we get 3, 27 over 3, 9 over 2, and 3, and the rest remains unchanged. 5, 0, 2, 5, 4, negative 4. Okay, now we can start subtracting. We can subtract the first row from the second row and then start getting our zeros. That was the whole point of multiplying the first row by 3. So let's do that then. Subtract first row from second. Okay, and after we've done that, we need to restore the first row. Okay, we can restore the first row to the original value, which is year. Okay, and I'm going to be doing this throughout. What is the point in making the leading coefficient there 1 if we're going to move to 3? So we can do that throughout. So I'm going to write restore first row. Okay, so I'm subtracting the first row from the second. Okay, so I'm just going to go down to the first row. We're going to get 0, we're going to get a quarter, we're going to get a half, and then we're going to get negative 3. We restore in the first row to 1, 9 over 4, 3 over 2, and 1, and the third row remains unchanged. Okay, the next thing we need to do, let's get rid of the 2 there. So we multiply the first row by 2. Okay, I'm splitting this step up to show you exactly what I'm doing. So the first row by 2, we're going to get 2, 9 over 2, 3, and 2. 0, 1 over 4, half, negative 3, 2, 5, 4, and negative 4. Okay, then we're going to subtract the first row from the third row and restore the first row, okay, to get, to pivot this, okay, to get this to 0. So let's write that down. Subtract first row from third row and then restore first row. Okay, so I'm going to write this down the bottom here. Okay, so if we subtract in the first row from the third row, let's do the third row first. So we get 0, half, 1, and negative 6. We haven't done anything to the second row, so it remains the same. 0, 1 over 4, half, negative 3. And we are restoring the first row. What was the point in getting the leading coefficient of 1 if we're going to change it? So we restore in the first row to 1, 9 over 4, nine over 2, and what was the... and 1. Okay, that's really difficult to see. But it's basically from here. Basically from there. 1, 9 over 4. That should be 3. Okay, let's put that up there. Really difficult to see. Okay, so that was restore first row. From third row. Restore first row. Okay, so we're going to get basically 1, 9 over 4, 3 over 2, 1, 0, 1 over 4, 1 over half, negative 3, 0, half, 1, and negative 6. Okay, do you see now we are slowly getting there? Okay, so now we're going to make the pivot in the second column. Okay, so we need to get this 1. That's not what I wanted to do. Okay. Okay. Okay, that needs to be half. Okay, so we need to get this lovely thing. We're going to pivot this, and we need to make that 1. Now, how can we make that 1? I want you to have a think. How can we make that 1? And I'm thinking as well. Okay, so we make pivot in second column by dividing second row by the magic number to make that 1, well, it must be a quarter. Okay, so we've got 1, 9 over 4, 3 over 2, and 1. We're dividing by a quarter, so we are going to get 0, 1, 2, negative 12, and 0, half, 1, and negative 6. Whew. Okay, so we are nearly there. We're getting there very slowly. Okay, so the next step. Okay, so we need to get now, we've got 1, 1, 1, we're getting there very slowly. We need to multiply the second row by 9/4, and I'll tell you why in a second. We need to multiply second row by 9/4. So this is the second row here. I want you to think very carefully why we multiply that by 9/4. Okay, we multiply that by 9/4 because we need to get these two the same. And then we can restore. We need to get these two the same. Okay, by the way, you can do this. You can use different numbers. You don't have to use my numbers. Okay, so let's multiply by 9/4. 1, 9/4, 3/2, and 1. Multiply by 9/4, we get 0. 9/4, 9/2, -27. And then we've got 0, half, 1, and -6. Now, can you see what we need to do next? We're definitely going to be subtracting the second row from the first. Okay, so subtract second row from first and restore second row. Okay, remember the point about restoring. Okay, we're not going to do all this work to arrive in echelon form only to knock it out from doing these multiplications and subtractions. Okay, so let's do that then. Subtract the second row from the first. We're going to get 1, 0, -3, 28. We're going to restore second row, so we're going to get 0, 1, 2, -12. And we get 0, half, 1, -6. Okay, we are nearly there. Okay, can you see? Now what we need to do is we need to get rid of this half here, and then we are home dry. Okay, just a quick note about this. So this is, I don't know, probably extension 2 maths or first year university linear algebra. I remember my professor at school doing this on the board, and he always used to make mistakes. I won't mention his name, but so even professors make mistakes and stuff like this. You know, you can have a 10 by 10 matrix. You just get a computer to solve that. So this is not difficult to understand, very easy to make a mistake. Okay, so next we need to multiply second row by 1/12. Okay, why would we want to multiply the second row by 1/12? See if you can have a think why we want to multiply this row by not 1/12, definitely not 1/12, by half. Why would we want to multiply that row by half? Well, surprise, surprise, we want to get this thing equal to 1. Okay, so let's do that then. So second row, let's do second row, 0, half, oh, it does not look like a half, it looks messy. We've got 0, half, 1, negative 6, then those are the same. 1, 0, negative 3, 28. Then we got 0, half, 1, and negative 6. We are nearly there. We are nearly there. Okay, now look at this. Look at this marvelous matrix. Okay, so we need these to be zeros for it to be in row echelon form. We need this to be 0, this to be 1 if we can get it to 1, and whatever this value, that is what z is equal to. So I want you to put your thinking cap on and think, what on earth can we do to this matrix to do that? Okay, still thinking. I'm still thinking as well. So, okay, so how about we, let's have a look, subtract. Okay, so we need to get this 0 and we need to try and get this to 1. Okay, this is not gonna work, and I'm glad we solved the system at the beginning using the elimination method, because we're going to get a free variable here. A free variable means it's equal to 0. That's what that means. So the only way we can do it is subtract second row from third row and restore second row. Okay, so let's do that then. 1, 0, negative 3, and 28. Then we've got, so a second row, 0, 1, 2, negative 12. And then we just got, if we subtract second row from third, we just got 0, 0, 0, 0. Okay, now we need to think very carefully. So z is obviously equal to 0. Or we refer to it as a free variable. Okay, so we did do it right. It's a miracle. It is an absolute miracle. Okay, so we're not finished yet. We've done all this work. So let's look really carefully at the solution now. Okay, that was a relief because, 30 minutes on one question. You would be leaving this question to the end. I would. And once if you're not explaining this, you can do this in 10 minutes. Okay. Okay. Let's switch to. Okay, so our final row echelon form is this. all this work, and we've got, disappeared, we got x, y, z, and this is the answer here. Let's put a bar. Okay, so we are left with 1, 0, -3, 28. We are left with 0, 1, 2, -12. And we just got 0, 0, 0, 0. Okay, so I'm going to switch to a different color. So what have we got? We've got x minus 3z is equal to 28. Well, that gives us 28 minus 3z. Okay, I would leave your solution like that. Or we could say x is 28. But make sure you put both down because you can't make assumptions here. Okay. Now, the second one is we've got y plus 2z is equal to -12. Well, that just gives y is equal to -12 minus 2z. And we can say that if z is equal to 0, -12. Okay, and if you scroll all the way back to the beginning of the video, you can see that I'm going to do this solution in, let's do this. So the elimination method, we are going Z28. Yeah, it's going to be the second solution, isn't it? We got Z equal to 0. We've got Y is equal to -12. And we got X is equal to 28. Brilliant. Okay, so I'm very, very confident that this is the right answer because we've used two methods to prove it. I hope this helps.